Hi, everyone. Welcome to the next episode of For Crying Out Loud. This time, we're going to be looking at the different kinds of severe weather and fronts with Miss B. So what does severe weather actually mean? Well, it's when severe changes from the normal everyday weather patterns happen. And you can have a temporary change, like a blizzard or a thunderstorm, that can last from a few minutes to a few hours, or it can last for an extended period of time, like a drought that can last for months or for even years. Now, some of the things we consider to be severe weather are high winds, excessive precipitation, thunderstorms, tornadoes, downburst waterspouts, they all go together. Tropical cyclones, which we call hurricanes in the Atlantic. Droughts, floods, blizzards and snowstorms and ice storms. And dust storms out in the plains of the United States. So when we left in March, we had just gotten started looking at the different symbols on a weather map. So if you remember, warm fronts are the red semicircles. Cold fronts are the blue triangles. A stationary front has the red semicircles for the warm front and the blue triangles from the cold front going in opposite directions. And then the occluded front has both the warm front and cold front symbols, but they're in purple. And I'm going to explain the difference among those four kinds of fronts. First of all, when you have a long, steady rain or a long, steady, quiet snow event, that's going to be a low pressure system in relation to a warm front. Now, that doesn't necessarily mean it's going to be warm temperatures, but they will be a little bit warmer than normal for that time of year. So you will see on these low pressure systems with a warm front, a long steady rain north of that front. The warm moist air is going to come up and over the cold front. You're going to get lighter winds, warmer temperatures, and you can even get rumbles of thunder, but they're not the severe storms that we're used to. So you can see in this diagram, you've got the cold air mass here, and the warm air mass is gently sliding up and over. Whenever you have warm air and cold air and the masses are mixing, you're going to get some form of precipitation here. This diagram shows it even better. It's a nice gentle slope. So cold air sinks, warm air rises, and the warm air will rise up and over the cold air. Now you can also get freezing rain and sleet, ice pellets because of this warm front. You can see the cold air masses down here, the warm air mass is pushed up and over, and it can overtake that cold air mass. It can freeze, and then you either get freezing rain pellets or you get the sleet. Now, the storms that are really severe in terms of tornadoes and thunderstorms and blizzards come from cold fronts. Now, cold front doesn't necessarily mean cold weather because cold front thunderstorms happen in the summertime. But you have warm, less stable air is ahead of a cold air mass. It's not behind like in a warm front. So it starts to rotate counterclockwise. And the lower the pressure, the higher that warm air is able to rise. Those clouds start to build higher and higher and higher into the atmosphere. And then the ability and the potential for that storm to become severe gets higher as well. So you get strong blizzards, severe thunderstorms, short and heavy downpours, high winds, hail, intense thunder, and lightning. You can see in this diagram, the warm air mass is in front of the cold air mass. It's all moving this way. And the warm air clashes with the cold air. There's no up and over gently. So when they clash, there's actually quite a confrontation. And there's such a difference between the two air masses that the collision creates some severe weather. You can see in this diagram even better where it pushes the clouds up. The higher the cloud column of cumulonimbus clouds, the more severe a thunderstorm it is going to create. Now, the other two kinds, you have a stationary front. Stationary fronts are when two air masses, you have a warm air mass and a cold air mass, and they're both of equal pressure and temperature. And they push against each other, but neither one's more powerful than the other. So they can't get past one another. One can't go over the other. And they stay put for a couple days. When the wind direction changes, one will weaken and the other will overtake it, and they'll finally move and become a solid warm front or cold front. So there's differences in air temperature and wind on either side of that front, because you have a cold front on one side and a warm front on the other. You get clouds all along the stationary front. You get rain. You can get snow. And if the front is in front of an area of low pressure, it can be stronger rains, more heavy rains, and more heavy snows. You can see again in this diagram, you've got a warm air mass pushing from here, a cold air mass pushing from here, and because they're of equal strength, neither one can push the other one out of the way. So clouds are formed right here at the boundary, and you can get rain that'll persist for days. Finally, there's something called an occluded front. So there is sometimes when a cold front is coming right behind a warm front, and in front of that warm front is another cold air mass. And so your warm front gets sandwiched in between. Cold fronts tend to move faster. The cold front overtakes the warm front, and now you've got this jumble of fronts that are causing some weather. So the cold air mass from the cold front comes over the warm air front. The warm air is pushed up, and you get a low pressure center. The precipitation along here are cumulonimbus, which are thunderclouds, and nimbostratus, which are rain clouds. Then, after all the rain and everything else, as the front passes, the wind is going to change direction, and you're going to get a clear sky and dry air. So you can see in this diagram, you have what looks to be a warm front right here. The warm air's up and over the cold air, but this secondary cold front is pushing hard against this cold front, and it's now pushed this warm air, and it creates a whole little low pressure area and storm center right there. So, some of the questions to think about: what is meant by the term severe weather? True or false, low pressure centers can have warm or cold fronts. Describe all of the weather created in a low pressure center with a warm front. And then describe all of the weather created in a low pressure center with a cold front. Which creates a stronger storm, a warm front or a cold front? True or false? Stationary fronts form where cold and warm air masses of equal strength and pressure meet. What kind of weather forms along a stationary front? How many cold air masses are involved in an occluded front? And how many warm air masses are involved in that front? And finally, what kind of weather forms along an occluded front? I will attach a document onto this video in the Google Classroom for you to write in your answers and submit them to me for some extra credit into the grade book.